Hello and welcome to another webinar of the series of Deep Dive hosted by the Open Source Initiative. We're going to be hearing today from Rohan Singh Rajput on fairness and responsibility in large language model-based recommendation systems, how we can assure ethical use of AI technology. I hope you enjoy the presentation. We're going to be taking questions at the end.
Hello everyone, my name is Rohan Rajput and today I will be talking about fairness and responsibility in LLM-based recommendation system. So in this session, we will be talking about how LLM-based recommendation systems can be used, what are the different problems we can face in future in LLM-based recommendation system. One of the key challenges here is fairness and responsibility. So we'll be talking about it. So this is the agenda. We'll go over what is LLM-based recommendation system. We'll go with brief overview about recommendation system, then LLM, what are the fairness problem, what are some of the potential solution we can propose, and what are the ongoing efforts and future directions. So I would like to start with what is LLM-based recommendation system. So before that, let's start what is LLM. As you all know that LLMs are like large language models. These are the systems that are trained on huge amount of textual data, primarily that predicts next word in a sequence. The popular example are ChatGPT, Google Bird, and recently Meta's Llama. These systems are trained on lots of different types of data, primarily text data from internet, research paper, and many other sources that actually help them to learn the association of different words, contextual information, and they can do variety of tasks. They can perform variety of tasks based on the requirement, right? One of the key aspect of these LLM-based system that they work on something we call prompt. Like we provide some kind of prompt, and based on that prompt, it work as a query. And using that query, they actually retrieve some of the information or generate as an output. So now let's talk about recommendation system. Recommendation system is a type of information, is a domain of information retrieval system. It's a kind of an information filtering system that provide some kind of suggestion to user. One of the popular example is Amazon. So when you open Amazon, you see this is the recommended item for you. Or in the various stream services like Netflix, we see that these are some of the recommended shows for you. Similarly, it can be used in multiple domains like music, online news. Google News is one of the example of machine learning based recommendation system. These systems are also being used in personalization. That means they can curate a user profile based on the historical data they are trained on. So basically what they do, they actually utilize lots of user and item feature, and based on user and item feature, they extract internal interaction of those user and item, and based on that interaction, they actually learn the various association, and based on those association, they actually recommend content for a user. Now let's talk about LLM-based recommendation system. LLM-based recommendation system is a very important field of the future. As we know that LLM systems can work in various domains. One of the important domain we have seen in LLM is basically natural language processing tasks, right? We have seen that like when we provide some kind of query, these LLM systems can actually provide us like, some kind of output, which is based on the query we query we put in the system. These queries are called as prompt. Now we can actually divide the future work of LLM-based recommendation system into two categories. First, it can be treated as a prediction task or a generation task. Now, what do we mean by a prediction task? A prediction task primarily are those tasks where we provide some kind of query to system. So in this example, if we can see that we have this, let me turn on the laser. Okay, so yeah, so here we can see that like we are asking to the system that, a user recently watched these movie and based on these, you need recommend some kind of, next movie to to this user. So based on this watch history, what are the best top 5 movie candidates you'll provide? Similarly, in the rating prediction, right, we say that these are the different ratings this user has given to these movies. Based on that, what is the most likely rating will be given by this user to this particular movie. So this is there. Now the second category of this LLM-based recommendation system is more advanced. So here, like what we are doing some kind of retrieval-based model that we have like something in inventory, and based on that inventory, we are like uh, giving some kind of output. Now the second category here is generation category, where we actually generate some recommendation for user. So one of the domain is conversational recommendation. It's like a chatbot kind of thing where a user provides some kind of input query that I recently watched this fiction movie. Please recommend something to me. And based on that, uh, you can you can talk with a recommendation system. It will provide you like some kind of recommendation. Okay, you watch this, so I should provide this, and then you get a oh no. Then you say like I don't like this movie, then provide me something else. And based on this conversation, the recommendation system can actually provide you uh, iterative recommendations. So this is also a new field of recommendation. And another thing that can be done is explanation of generation. That means that you know you provide like some kind of movie that a new movie named Godfather 2 is recommended to user who recently watched this. Please explain why this movie is recommended. So it can help us like to provide explainability to user, and that means that based on like certain set of movie, uh, our recommendation system can actually generate some kind of explanation that because you watched this type of movie before, and that's why I'm providing you this type of movie. So these are like different uh, categories of recommendations that actually can be used using this large language model. Now there are various open source library available, as this is an open source uh, deep dive conference. Uh, these are some of the libraries. There are like tons of libraries, but I found like these are the like most popular one library that can be used to build a recommendation system. One of the like I think important note here that some of the libraries are very extensive, like Microsoft Recommender or NVIDIA Merlin, which are very specialized for certain kind of recommenders. So for example, if we talk about NVIDIA Merlin, it has a capability to run like large scale recommendations on like GPU clusters. It can also have like various types of uh, hyper optimization has been done to run large transformer based architecture or like different type of complex deep learning based architecture on GPUs. So it's a very computational efficient library, and it works pretty well on like uh, large GPU systems. Similarly, in Microsoft recommender system, it provides you like a whole package of lots of recommender system. So it actually gives you some kind of freedom to take your data and run multiple types of models or multiple types of recommender system to see that what fits best for your data, right? So these are like some of the open source library for recommender systems. Now, here's the topic we'll be discussing about. Like now we have talked about like what is recommendation system, what is large language model system, and how can we combine these two uh, domains to generate a new domain. It's called LLM-based recommendation system. Now, in this LLM-based recommendation system, there are like lots of fairness and ethical issues that we should be addressed in the future because those will be very important in success of this system. So first and most important, like fairness and bias in LLM-based access. Now, as per se, like recommendation system or LLM system, uh, they are trained on like historical data. If the data contains some kind of bias, that kind of bias can be replicated by these kind of systems, so that these kind of biases can be projected by the system. And how we can make sure that uh, these all these issues don't impact the output of our recommendation system. So one of the few important domains to address fairness in LLM are education, criminology, finance, and health. Uh, Before that, I just want to discuss something more about LLM-based system, that because LLM-based systems are trained on like huge amount of textual data, and inherently it can actually tries to like incorporate some of the like biases, stereotypes in the system that can actually impact the performance of the recommendation system also. And that's why some of the like very key or sensitive domains, we should be very, very careful using an LLM based recommendation system. So take an example of healthcare or finance, right? Our system should like give like equal opportunity to every community to give like fair assessment to like certain kind of like financial advices. So for example, like we are quoting someone like some kind of uh, let's say mortgage or like loan or any kind of financial help or financial advice, we should make sure that like the system is giving uh, appropriate recommendation, unbiased recommendation, and it's very fair to uh, every community or every gender or very other like social aspects. So those things should be taken care properly. Uh, One of the thing we want to address, like there are like multiple dimension of recommendation. So I think the fairness dimension we would like to talk here are like statistical parity, equal opportunity, equal odds, overall accuracy, equality, and counterfactual fairness. That means that within these dimensions, we should make sure that like our system is working appropriately. We have seen, based on this paper, Fairness of ChatGPT by Yungkai et al., the ChatGPT has comparatively high fairness score than traditional recommendations, traditional model, for example, like a regression or a multi-layer perceptron model, but they still have some kind of fairness issue. And those type of issues should be properly dealt with before like, launching any kind of system. Again, extending that idea, we have seen like there are some of the like very obvious issues in LLM based models, uh, and one of the important issue is hallucination, and which is a very important one. Why? Because it can actually impact like decision making of a user, because recommendation systems are known for impacting user decision process. We should make sure that like the decisions coming from those recommendation system, LLM should have like, uh, as we can say, like, as much as truthful influence as possible. Now, the problem of hallucination is like generating an unreal content. For example, that if we are generating some kind of product description, it should be not like, it should not be false. It should not be misleading. That is a very big problem by itself. Like you're launching like some kind of product and your LLM system is like, actually writing a description for it. So you should make sure that the description it is writing is not very misleading to user. Same goes for like not, you know, generating some kind of item recommendation that is not available in your inventory, right? If somebody asking like, okay, give me like, let's say, uh, uh, for example, uh, in some kind of product, you're looking like, okay, give me like iPhone 13 within, let's say $100, right? You should not generate like a few image of an iPhone that actually gives a price tag of $99. Like that doesn't exist. But yeah, like it is like it's kind of misleading marketing. It is doing like it is just giving like some kind of wrong recommendation to our user. The second, if we extend this idea furthermore, in conversational AI, this problem becomes like more severe, right? Our system should not suggest like some kind of unrealistic solution, right? If somebody is looking for like some kind of weight loss advice, our system should not be saying that you should stay like hungry for next 7 days, or you should not eat that and that, like, which is very unsustainable, or also sometimes it would be very dangerous to our user. So we should make sure that we have like all the proper checks in place so our system does not make these kind of mistakes. Again, another thing we can talk about is fabricating an information, that it is not like generating some kind of like a random fact which are not true, or like forging some kind of ideas, like instilling some kind of like uh, wrong information or giving some kind of advice that is not true, that could be like misleading or harmful to user. So all of this thing, like we should make sure that like our system is very resilient toward these kind of uh, uh, harmful issues, right? So yeah, that's one of the important aspect of recommendation system, that we make sure that we don't have like this hallucination problem in which impacts performance of our recommendation system. So what could be a solution? Yeah. So one of the solution could be that we should have very robust data and algorithmic pipeline. These are like several solutions I listed out here, but like we can talk about them one by one. So one of the important thing, like we should have like a very robust data processing pipeline. That means we have like a strong measures in bias identification or augmentation, right? One of the example we can see here, that like these are like some of the very sensitive attributes that we should make sure that are not influencing the decision making of our model. In movie length data, we have seen that there's a lots of gender, age, or occupational attribute that actually influence the uh, output of the movie length recommendation, right? Or rating. Same goes in the insurance data, that we have like marital status or like insurance, like occupation or age, and these actually attributes are contributing toward the decision making of those systems, right? We have to have like some kind of algorithmic fairness. That means that we should put certain kind of checks, that actually certain kind of constraint, that our system should not produce any kind of bias towards a certain set of members, right? Or like we have some kind of constraint that it should work within those constraints. We can also include like multi-objective optimization. One of the example is that suppose we are building like an engagement-based recommendation system, And in that engagement-based recommendation system, we also want we don't want to optimize for user satisfaction, but we also want to incorporate diversity. We want to give a chance to fair chance to uh, other stakeholders. We have a music streaming application, so we want to give fair chance to all the artists like uh, to get their music presented or promoted on on a user screen. So everybody should get fair chance to get promotion. uh, so we have to include these kind of optimization to the system itself, so our system learns that these uh, these are the other objective I should also optimize. I should not only looking for improving the click-through rate or improving the let's say user satisfaction. We should also do post-hoc transparency solution, and it's very important. We have to do some kind of fairness audit to make sure that it could be a human in the loop solution where some expert actually regularly check that, yeah, the system is fair. It is not you know uh, diverging from our mission or our fairness constraint. There is some kind of governance there, there is some kind of guideline that it should follow. You should also have some kind of feedback loop that if the system does certain kind of this unfair recommendation, we should have some kind of penalty incorporate in the system, so a system can actually learn from those penalty and don't improve itself. Observability plays very important role here. We should know that if there is any kind of data drift or model drift or concept drift is happening, our system actually you know track those things, alert to uh, respective stakeholders so they can actually address those problems. uh, Explainability is very big part. We should be very transparent. like Honestly, making machine learning algorithm transparent or explain is a very difficult task, especially in field of large language model or neural network, right? So the deep learning based systems are inherently very complex to understand because they have a very high dimension interaction, which is very difficult to visualize. But we have to make sure that we use a system that can give us some sort of explainability about their recommendation. We should have some kind of user control also, right? If the system is deviating in certain direction, then we have to interject and fix those problem right from the beginning itself. The third thing is diversity and compliance. That means, as I mentioned previously, that we should give fair chance to every user group or every uh, artist group. If we are talking about a music system, uh, every part of the community is getting equal chance to get represented, right? Those things should be incorporated in the system. We can also put some kind of regulatory compliances that said there should be a ethical or guideline or legal requirement should be there, that we make sure that our system is fair. So what are the some of the ongoing efforts and the future directions uh, going around in the field of recommendation system? The first is that user education and monitoring, that we have to make sure that our user understand that what type of fairness metrics we are using, how we are generating certain kind of recommendations, and how these recommendations giving equal chance. It could hurt certain segment of community, so we have to provide a proper explanation that why we are promoting this content and why we are not promoting that kind of content. That kind of uh, information should be given to user so they actually can you know uh, receive it firmly and also act upon it. We can also implement some kind of real-time fairness monitoring. That means if there is a certain kind of metrics are deviating from here, each deviating from the core objective, it actually gives a alert. It also help us to intervene. It helps us to monitor that It's why our system behaving in a certain way and what we can do about it. Uh, Third-party audits and community involvement. So we should not be only the arbiter of truth. There should be like, other the third parties who are specialized on like this unbiased evaluation that actually help us to gain the credibility of the system. We also make sure that we don't want to we don't incorporate our own biases in the system, other than like get all the perspective from every party to make sure that our system is working as expected. uh, we can also incorporate like public input on defining and measuring fairness, right? That means that we can actually uh, do like user survey to understand. We can also do like a little bit of marketing research to understand that how user perceive uh, fairness in recommendation. One of the important thing we can do like under like act upon user feedback. Sometimes like user provide us some kind of feedback. We should always seek the feedback. We should always keep open this channel that like our user provide their their experience with us, and based on that experience we actually improve our system, because that helps a lot. That actually uh, it works in our favor, right? Because our user actually provides the vital information which sometimes get missed by us. It's not possible for every person, like one person, to audit all the recommendation like generated by any kind of model. But when we get like user feedback, we can actually go and like address those problems specifically, like individually. Like we can take those problem and resolve it. So as in the conclusion, fairness is not just a technical term. It's a very societal term. We have to incorporate like all the stakeholder. We have to understand various aspects of recommendation system to make sure that what we are suggesting is fair one. Uh, and also like there is it's not one time process. It's a very iterative process, and we have to like go through like continuously. Sometime it says it's a very open problem also. It cannot be solved like just with one kind of metrics, or it cannot be solved with one kind of system. It has to be continuously evolving. It has to be like pretty much reactive. uh, we have to also make sure that like what kind of optimization we can do in like what segment. Maybe we can never achieve it, like, but we have to make sure that we reduce this as much as possible. So with that, I think I would like to conclude my presentation. Thank you so much. And if you have any question, please connect me on LinkedIn. I will be glad to answer your queries. And uh, yeah, with that, I conclude my presentation. Yeah, so thank you so much and have a wonderful rest of your day.